If an assignment can be solved by AI in seconds, then it is not building real math understanding. The challenge is to design tasks that demand more than just an answer. Here's the shift that we have to adapt as educators. The old goal is to write f of x equals 2x plus 3. The new goal has to be to see the relationship, explain it, test it, and defend it. When you explain functions to students now, you're going to say, you're not just learning to write equations. You are learning to spot relationships, choose models on purpose, and justify your decisions. So what does proficiency look like now? It looks like being able to detect patterns across a table, a graph, a rule, and a story. It looks like predicting how one change affects another and explaining why. It looks like choosing a function for a context and defending it against other options. It looks like catching AI's mistakes and fixing them with evidence. And it looks like documenting what AI helped with and what required their own reasoning. So here's how to make that shift in your classroom. You can use AI as the generator and challenger. You have students prompt AI with something like this. Give me a table, a graph, and a description, and an equation for the same function. Then have them identify what stays the same, what changes if the slope grows or the intercept shifts. Something like tackle messy data scenarios. Give students messy data, something like a rideshare table or a streaming plan. Have them ask AI for a function, then have them critique it. Where's the AI wrong? What assumptions does it make? Could a different rule fit better? You can have them run function battles, where you have students work through scenarios like this. One job pays $15 an hour, another pays $10 per hour, plus a $50 bonus. Students have to model both, graph them, and argue which is better, 5 hours and 20 hours. You can do create and break functions, where you push students to create and break. For example, have students make a steeper slope than the class example, or create a nonlinear function that matches 3 points, then diverges. Divergence matters because in real life, two different models can fit the same data for a short stretch, but lead to completely different conclusions over time. And students need to see that choosing the right model is not just about what works right now. It's about which model holds up as the situation continues. You can have students build portfolios and not worksheets. Do not just collect worksheets, collect portfolios. And you can do this by having students use AI to make a graph. Then describe the story it tells and its limits. You can then reverse it by starting with the scenario. Name the family of functions and test it. Students can critique an AI claim by explaining how or why it misleads. Students can become creatives by inventing their own function story and show it in 4 different ways and justify it. So with portfolios, every artifact should include what AI clarified, what required reasoning, the exact prompt they used, and how they refined it, and one voice check sentence in their own words. And what you need to do is now grade what really matters. You can decide how you want to grade students' work, but you should be grading for the following criteria: input and output explained with meaning, accuracy across representations, the critique of AI with evidence, the student's original creation with justification, reflection, and prompt strategy. Functions are the heartbeat of algebra. They drive physics, finance, coding, and even social science. But if students only plug in, AI will hand them answers they cannot defend. Your job is no longer to stop AI. Your job is to make students think harder, see deeper, argue stronger. So make the shift from plug in and get out to ask, test, defend, and revise. That is how we make math assignments cheat resistant. That is how we build fluency that lasts. What's one move you're going to try this week? Put it in the comments below.